Okay, so we're done with Unit 3, and we're diving right into Unit 4. In fact, we're diving deep into Unit 4, starting with Unit 5. We've kind of gone through scientific notation pretty thoroughly, and we're going to start with evaluating expressions with radicals. And by the end of this, you should be able to solve problems involving the order of operations with radicals, including exponents with radicals. Okay, but before we get into the meat of this lesson, let's review our exponents, like everything squared and things like that, and cubed specifically, because on the test you're not going to be able to use a calculator, and it's good to kind of know, you know, your squares and your square roots, which is the opposite of your squares, up to at least 13, I think. All right, so you have your n, that's just a number, okay, and n represents 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or 13, okay? And I recommend that you do this at the beginning of your test, okay? And if you have n and it's squared, it's going to be your final value, or your final, I'm getting blurry here. Let's do a focus. If you square n, it's going to be 1. Remember, squaring is multiplying the number to itself, right? So 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, and 13 squared is 169. And the reverse of that is square root. Square root of 169 is 13, 1 square root of 144 is 12, 121 is 11, square root of 100 is 10, square root of 81 is 9, square root of 64 is 8, square root of 49 is 7, the square root of 36 is 6, the square root of 25 is 5, the square root of 16 is 4, the square root of 9 is 3, the square root of 4 is 2, and the square root of 1 is 1. Okay, so that was a mouthful, but we're going to do the cube roots now. Okay, so the cube roots, that is, if we say, or the n cubed, right? If I cube one, that's 1 times 1 times 1, it's 1. 2 times 2 times 2, or n cubed is 8, or 3 cubed is 27. 4 cubed is 64. And then 5 cubed is 125. 6 cubed is, this one's always the tougher one. 6 cubed, 6 times 6 is 36, times 6 is 216. 216. So that's, I mean, up to 6 I think is always like reasonable, right? Beyond, I mean, this is 1,000, it's pretty obviously. This is 719, I think. This is 216. This is 343. This is 512. This is 229. Yeah, and these I don't remember, right? But you know, these I don't think are too pertinent to memorize, but these are very helpful if you memorize. Okay, these ones here, 1 through 6. All right, so definitely know these. Your world would be a lot easier if you know these. These are a little, your world will be super easy if you know these ones for sure. And remember, when you square a positive or a negative, it will become a positive. If you cube a negative, it is still a negative. Okay. Okay, so because anything raised, anything a negative raised to an odd number, it will yield a negative. Okay, that's the outlying weird thing. Okay, anything raised to a negative is still a negative. Sorry, excuse me. Anything a negative raised to an odd exponent is still a negative. Okay, as long as the negative sign is the thing being raised. It has to be within the parentheses. So anyway, so a couple refreshers there. All right, so that was 5 minutes. I didn't want to get into that too much. All right, so refresher on radicals. Okay, so let's zoom in on here, this radical thing. All right, so this is the radical bar. Okay, now this area here is designated for the index. This is the index area. Okay, if there's no number written here, that means that there's an invisible 2 sitting right there, meaning that it's asking for the square root of whatever is in here. This thing in here is called the radicand. This is the radicand area. Okay, the radicand is what they're taking the square root of, right? So if, for instance, they have the square root of a number, we'll say it's 25, right? And there's no number here. The square root of 25 is 5, right? It's asking, hey, what do I need to multiply itself by 2 times, because it's an invisible 2. What do I have to multiply by itself 2 times in order to get a 5? Another way to think of it is like, hey, I need to multiply something by itself 2 times. So 5 times 5 equals 25. There are 2 things under the radical, right, in order to pull one of those things out so that there is only one thing left, so there's nothing left inside of it. Because remember, there's an invisible 1 inside of their things all the time. You're multiplying stuff by an invisible 1, right? So there's 5 times square root of 1, and square root of 1 is always going to be 1, so the radical goes away. Okay? So another way to think about it is, hey, well, the reason I say that is it'll see a little bit more obvious if I go, hey, what is the cubed root? The cubed root of like 27. Okay? Well, the cubed root of 27, we'll say negative 27. Negative 27. Okay? Well, in order to get negative 27, I need 3 negative numbers, when multiplied together, are 27. And they have to be the same number. Okay? Well, 3 times 3 times 3 is 27. But if I take negative 3 times negative 3 times negative 3, I will get negative 27. So I need 3 of the same numbers pulled out of this radical in order to escape the radical. Right? In order to escape this radical, 3 of the same numbers must be joined together, and only one of those radicals get pulled out. Only one of those numbers. 3 combine to get pulled out as 1. Right? So 1, 2, 3 combine together, negative 3, and then what's left inside the radical is not 0, but a 1 is left inside the radical. Okay? So that square root of 1, or the cube root of 1, is still just 1, right? So this now becomes negative 3. Our radical disappears. Okay, so that's how that thing kind of looks. All right, so now let's look at factor trees. I'm going to erase this so we have room to look at the factor trees. Let me pause this to get an example. All right, so say I have this number 729, and I want to factor it into its all of its factors. All right, well, I can look at this thing, and I look at the first 2 digits, and I say, well, I got a 72, and I got a 9. And I'm thinking, oh, well, I could divide. It's not a even number, so 2's not going to work, but I have 72 and I have 9 here, and I know that 72 is divisible by 9, by 8, and then 9 is divisible by 9, so I'm going to divide this thing by 9. Okay, so if I do 72 divided by, so if I go 729 729 divided by 9. I go, that's 8. This is going to be 72. And it's going to be 0. It's going to be 81. So this is going to be 81 times 9. Okay, those are two factors there. 81 times 9 is going to be 70. It's going to be 72 times 9. And then I know that this is going to be 81 breaks into 9 and 9. And this is, so I have 3 9s there. Okay, so I know that this is at least 9 cubed, because 9 times 9 times 9 is 3 9s. It could also be, no, 9 cubed is true. Okay, so then this is, I know that this is 9, 3 times 3, and this is 3 and 3, and this is 3 and 3. So it could also be 1, 2, 3, 4, 5, 6. It could also be 3 to the 6th. Okay, so it could be 9 cubed. It could be 3 to the 6th. It could be 9 squared. It could be 9 squared times 3 squared, right? Because this one and this one, right? So there's a lot of stuff that this thing could be, right? But either way, that's the different ways that you could do this factor tree. All right, so what if I had a factor tree under a radical? Right, I don't know if you understood that. Let me show you. All right, so this is, did I say 9? This is not 9 cubed. This should be 9 squared. So this could be 9. So we have 9. This could be 9 squared, and then 3 squared. So that's why it could be 9 squared and 3 squared. And then 9. This could be 9 cubed, and then 3 to the 6 is this one. Right, so it's different ways that you could do that, in case that wasn't obvious. All right, so here we go. If we have a radical, if we have factor trees under radicals, right? So if I had that same 729 under this thing, you carry the radical down, and you're like, hey, I'm trying to find the cubed root of this, right? I'm trying to find the cubed root of this thing, and you're like, okay, well, I need 81 times 9, and you're like, okay, well, I don't have 3 the same thing yet, and now I have 81. Whoops. Now I have 81. Now I have 9 times 9 times 9. Hey, look, I have 3 of the same numbers. So now, since I have 3 of the same numbers, I need 3 of the same numbers to pull out 1 of that number. Right? So these 3 go away. I pull 1 of them out. Now I have 9 times the cubed root of whatever's left inside. And I got nothing left inside, so there's a 1 left in there. Right? So now that cube root of 1 is 1. That goes away. So this is just equals 9. Okay, so that's how that whole thing works. All right, so now let's bring all this stuff together and work out a problem or 4. Okay, so here we go. We got this one right here. Now you got to look at your order of operations. Remember PEMDAS. Please excuse my dear Aunt Sally. All right, first thing you do is work everything in parentheses. There's nothing in parentheses. Then you work your exponents. A radical is treated like an exponent, okay? Because technically it is. Technically this is 225 to the 1/2. But, you know, save that in your brain for later, for algebra, okay? But anyway, so this is negative, the negative. So up here we have a positive. This is a positive. That's going to be positive. Down here we have a negative thing. So a positive divided by a negative. This whole thing is going to end up being a negative fraction. All right, so just kind of like get that negative sign out in front and forget about it, okay? So and up here we have this 5. So now we have this, look at these 2 exponents. All right, so 3 to the 4th. So 3 times 3 times 3 times 3. Okay, so we got this 3 times 3 is 12. This 3 times this 3 is 12. 12 times 12. Oh, I didn't do that. It's not 12. What am I thinking? All right, this is 9 and 9. 9 times 9, and then 9 times 9 is going to be 81. Okay, so there you go. This is 81, and then we have 5 up there still too. Okay, now we have the square root of 225. Right, so we're going to work that over here. Square root of 225. Well, 25 is an awesome thing to do. Right, we have the square root of 225. So we have 25 times 2. Okay, well, 25 times 2, we take this 25 out. The square root of this is going to be a 5 times a 5 times a 2. We have 2 5s. The square root comes out as a 5. Now we have 5 times the square root of 2. Okay, well, you remember that the square root of 2, actually, hold on. I just realized something. So this square root of 225 is actually 15. It's actually 15. That's actually an easier way to do this. All right, square root of 225 is 15. All right, so this is 15. Okay, so from there you go 5 times 81. So I'm going to multiply this by 5. 5 times 81 is 5. This is going to be 40. So this is negative 405 divided by 15. Now, so 405 divided by 15. This is going to be, let's see, it's going to be 2. Right, so it's going to be 30. Subtract that. That's going to be 10. Bring down the 5. And then probably 7, I think. So 5 times 7 is 35. So I put 35 right there. Wait, no. Yeah, so 7 times, so 7 times 15, that's 35. 7 times 7 times, that's going to be 35. 105, yep. So that's going to be 105. Right, so this is going to be 27. So this equals negative 27. Okay. All right. So then we go over to this one. Okay, we have to do a little bit of substitution here. So it says z is negative 27. So this is negative 27. So let's look at the cubed root of negative 27 first. So we have the cubed root of negative 27. Well, we did this up here, right? So we're like, okay, what do we need to multiply by itself 3 times to get 27? So negative 27. Let's look at just 27. 27, what are the things at 27? We have 9 times 3, and then 9 is 3 times 3 times 3, but it has to be negative, so these all have to be negative. These are all cubed roots. Right, so the cubed root of negative 27 is, we have 3 of the same thing, negative 27, so a negative 3 has to come out, leaving behind a 1, so this is 3 times the negative 3 times the cubed root of 1. That goes away, giving us the negative 3. So this term can be written as 6.2 plus negative 3 divided by 12. So this is going to be like, this becomes a 6.2 minus 3, and that's going to be 3.2 divided by 12. So 3.2 divided by 12, whatever that becomes. Showing the math, it's about 3.2 divided by 12 equals, 3.2 divided by 12 equals that. Convert that to a fraction decimal, is 4/15. It's 4/15. Okay, I don't think you're going to have anything that complicated on the test, and if you are, I'm going to let you use a calculator. So anyway, all right, here we go, going on to this one. All right, so here we have a 18 minus 2 times the radical of 121, square root of 121. It's a square because it's invisible. Okay, well, if you memorize the tables, you know the square root of 121 is 11. Okay, so we go 18 minus 2 times 11 divided by 2 to the third. 2 cubed, if you memorize the tables, is 8. Okay, so, or you can just be like, okay, this is 2 times 2 times 2, which is 8. Okay, so now you have 2 times, so this is 18 minus 22, because 2 times 11 is 22. 18 minus 22. Right, remember we multiply, then subtract. Okay, divided by 8. Okay, now you have to subtract the top, then divide, right? Because technically this is 18/8 minus 22/8, if you want to be technical about it, right? Either way, it's the same. So 18 minus 22 is 4/8, which is 1/2. So, whoops, you couldn't see that. So there's the answer to that. Okay, so there's that. All right, so here's this one, and this one is working inside a cubed root. Right, so first thing you got to do inside this cubed root is square the 6. So this is the square root of 100 minus 36, because 6 times 6 is 36. So this is the square root of 44, because 100 minus 36 is 64. What was I thinking? 64. 64. 64. Okay, the cubed root of 64. All right, so I don't be falling in the trap. That's a nice square root. A nice square root is 64, right? It's 8, right? But it's asking for a cubed root. Okay, so now I need to break this thing in and see if we can find 3 of the same number. So let's take this up and do, let's see, 8 times 8 is 64. Now we can break this up into 4 times 2 times 4 times 2. Okay, that's 8 times 8, right? And now we can break this up into 2 times 2 times 2, as this set, times 2 times 2 times 2. That is this set. Okay, so do we have 3 the same number? Yeah, we do. We have this group, and we have this group. Right, so we can bring this out, and we can bring this out. You can't see what I'm doing. I'm sorry. So this was our first 8. This was our first 8 breaking up into 2. This was our second 8 breaking up into 2. 4 times 2. And now this was this 4 times 2 broken up, and this was this 4 times 2 broken up. Okay, so when we break these 2 up, and this is a cubed root, and this is a cubed root, this is a cubed root, we need 3 2's, because this is a cubed root, to come out, and we have these 3 2's that can come out. They both come out as a single 2, right? So when we have that left, we have 2 times 2 times a cubed root of 1, right? Which is, the cubed root of 1 goes away, so we just have 2 times 2, so we have a 4 left over. All right. Okay, so that is that one, and we'll move on to the next one.